Hello everyone, it's me again. So this episode will be basically going through all the synthetic reactions that you have learned. I'm pretty sure many of you hopefully had made notes about all the reactions that I've told you. And if you have not, this video is for those who have not done anything in the holidays, or those who have done but have not organized their thoughts in written form. So this will be really beneficial before my classes on Monday to Wednesday, because I will not be going through anything basic anymore. So I will assume that you know every single thing, all the reactions memorized. So let's begin. So I'll be splitting into different functional groups. So we'll start with the first one, which is alkane. Now alkane, we have learned this in book 3A, okay? Book 3A. And the first one will be substitution reaction. For example, if I have ethane, if I add Cl2 UV, I will be substituting one of the hydrogens into the halogen. So if I'm using Cl2 chlorine, I will be substituting it into a haloalkane. Okay? So this is an example of substitution reaction. And the details for this one, please refer to book 3A. I'm not going to be talking too much about it. For example, the reaction, for example, initiation, propagation, and termination. Obviously, when you're doing synthetic rooting, you will just need to know how to write this. All right, moving on. For alkane, that's it pretty much. There's only one reaction. So it's really easy. So you'll notice it's alkane turning into haloalkane. Now, of course, you'll be like, what about combustion? Now, that is also one of the reactions, but if you ask me if you remember the synthetic rooting, you don't need to know that. So moving on to alkene. Now, alkene, you have to pay attention because it's one of important functional groups, because it can go and undergo different reactions. So the first one we have learned in book 3A is if I have an alkene and I have bromine in organic solvent. So this organic solvent is usually CCl4, okay, tetrachloromethane. I will be adding Br and Br over here. Okay. So this is an example of addition reaction. Excuse me. So example of addition reaction is when alkene substituted by Br2. So you can use Br2 or Cl2. Same thing for this one, you can use Br2 under UV, and I will get dibromoalkane. So this is a relatively simple one. So the takeaway over here is the organic solvent CCl4. You must write this. All right, another thing you have learned at the beginning was if I have alkene, if I oxidize it, what will I get? So oxidizing with KMnO4, and then acidic or alkaline, depending on which one you like. So there's no preference here. So I will be substituting with 2 of the OH. All right, diol. Again, if you forgot about this, please refer to book 3A. So both of them are actually used to test unsaturation. So if it's alkene, bromine will decolorize, so yellow-brown will decolorize. And for this one, if you're using this one to test for unsaturation, purple will become colorless. Now these two are the common ones. Now the third one requires, it's in book 3B, or not 3A anymore. So in this one is in book 3B. So if I have, for example, alkene, and I add HCl gas. So it can be HCl or HBr or HI, depending on what haloalkane you require. I will be getting H and then substituting with BrCl or I. Now this one you have to pay attention because this is a symmetrical alkene. Now for instance, if I have asymmetrical alkene, and I have addition reaction, HCl let's say, where will the H be going? Okay, where will the H be going and where will be the Cl attached? For this one you don't have to worry because they're HH, so you can just substitute anywhere you want, it'll be the same compound. However, if I substitute Cl over here in the first carbon and substituting Cl over the second carbon, I will have two different products. So how do I know which one is correct? So this is where Markovnikov's rule come in, okay? So Markovnikov's rule states that the carbon with more hydrogens attached, the hydrogen of the reactant will be attached towards it. So in this case, the first carbon has two hydrogen, okay? And the second carbon has one hydrogen and one methyl group, so I count it as C. So obviously the first carbon is attached to two hydrogens, so this hydrogen will be attached to here. So the final the product will be something like this. So I have H here, H. So copy everything first. So H, H, H. So the H over here will go over here instead, and the Cl remaining will go over here. So this will become major product. Alright, so usually we write down major products only, unless it's specified. So you write two of them. So major is this one. If they ask you to write minor, you do the add sign, and then H will be here and Cl will be here. Okay. So just be careful for this part. Right? You have to apply the rule. So we have 1, 2, 3 already. Now the fourth one is if I have alkene. If I have alkene, I add hydrogen, cadmium or platinum, I can get rid of the double bond. So I will get alkane. So this is elimination or dehydrogenation. So I turn alkene into alkane. Alright? So there's no such process of alkane directly forming into alkene, all right? So just be careful. So elimination. So the only way to form alkane is through alkene. And the final one, which is very rare, but many of the students always forget about this. And in the textbook, it's only been mentioned once. So if you pay attention to the charts, like its summarization, in summary, they will not add this one usually. So, but I still want you to add it in your rough work or your notebooks. Okay, is this, if I have alkene, and if I have Br2, aqueous. Now, be careful, the aqueous over here is different than here one. Here, the first reaction over for alkene is organic solvent. But if I don't use organic, I use aqueous, which means there's water inside the solution. What happens is that I will still be undergoing substitution reaction, but one will be substituted with Br and the other will be substituted with OH, because the water from the aqueous solution will be substituted over here. So I'll have Br and OH at the same time. It's quite rare for the question to give you the final product as this one, but if they do, you know that it's coming from alkene. Alright, so heads up for this one. Now, if you want to look at which textbook, which page is this on, it's actually on page 84 of book 3B. So, if you have time, please make sure to go through it briefly. Now, we mentioned alkane only. So now we move on to the third one. The third one is relatively simple because it's only one reaction. All right. So the third one is haloalkane, reactions of haloalkane. Now for haloalkane, there's only one. For example, if I have a Cl attached to this ethane, all right. If I have NaOH and reflux, what happens is that the Cl will be replaced with the OH. All right, it's a very common one. So I will have a alcohol instead. So this is a substitution reaction, and there's only one for haloalkane. Now moving on to the fourth one, we will be talking about alcohol. Now alcohol, it's also another big reactions, a lot of reactions for alcohol. So I'm going to break it down into different parts. So the first one, you have to memorize again, because there are many different reactant will use different catalyst. All right. So the first one, if I have alcohol and I want to get haloalkane attached with chlorine, so I can use PCl5. Now I'm just showing you one of it only. In reality, there are three reactants you can use to form Cl. Okay. So this will be on page 101 of book 3B. But I usually memorize PCl5 because there's nothing else to add, the easiest. Next one, if I want Br formed, I cannot use PBr5, there's no such thing. Instead, I have to use red phosphorus plus Br2 and under reflux condition. Now notice, the first one does not require reflux, all right? This one requires reflux if I want to form Br. Similarly, for iodine, red P plus I2 and reflux, I will get I attached. So different condition will yield to different products. So this is actually still substitution reaction. We're just substituting OH with Cl. So please do not confuse with haloalkane. Haloalkane is in one way, it's halogen with sodium hydroxide, I'll get alcohol. But if I want to reverse, then I have, for example, if I look at this one, if I want to go from alcohol to haloalkane, I have to add PCl5. All right, next one will be oxidation of alcohol. Now oxidation, many of you I think have memory of it. So if I have a primary alcohol, that means the hydroxyl group is attached to the carbon, only one carbon. I can undergo oxidation. So usually oxidation, the reactant is Kr2Cr2O7. All right, potassium dichromate, and acidic, and it must be under reflux. Now sometimes you will see potassium dichromate or potassium permanganate. So remember, potassium dichromate is the stronger one. All right, it's a stronger oxidizing agent, whereas potassium permanganate is a weaker one. So that's why we always use this one. But sometimes you will see textbooks using potassium permanganate. That's fine. So if it's a primary alcohol, I will get aldehyde. And then after aldehyde, if I keep going, the same reactant, I'll just use O to represent this, I will get carboxylic acid. Now if I have a secondary alcohol, so which means is the carbon over here is attached to two carbons. It's a secondary one. Again, undergo oxidation, I will get ketone instead. Okay, this carbon over here will form into C double O bond. So remember, there's no continuous step after this. Alright, that's pretty much it for alcohol in terms of oxidation. Now moving on to elimination. Okay, so we're just gonna categorize this. Alright, for elimination. If I have alcohol, for example, OH over here, I can actually form alkene directly. So I can get rid of H and OH, these two go away, and then it forms a bond. So, but I will need concentrated H2SO4 and 180 degrees or heat, so I can get this one. And finally, esterification. So if I have alcohol, remember, alcohol plus acid is equals to ester. So I've mentioned this before your holidays. So if you've forgotten, please refer back to your textbook. So alcohol, I just have to add a acid. So let me see, I'll use CH3COOH, ethanoic acid. And the condition will be as well, you need a bit of acid. So this is the reactant, and I need concentrated H2SO4, the catalyst. So remember, what happens is I got CC, the weaker one, the one with OH, will be only with O. Acid will have C double O bond and then C. So this is, how do we name this? So it's ethyl, this one is ethyl ethanoate. So remember, you cut here. So again, if you have forgotten how to name, please refer back to the first video, carboxylic acid, part 1 and part 2. How to name them. It's a detailed explanation over there. So you will notice there are 1, 2, 3, 4, 5, 6, 7 reactions of alcohol, 1 reactions of haloalkane, and then over here we have 3 plus 2 is 5, and 1 reaction for alkane. So by now you should be already memorized 14 reactions. And we still have aldehyde and ketone. Now aldehyde and ketone are relatively easy because it's just the one-way reaction. So for example, 5th aldehyde or ketone. So if I have aldehyde, let's say this one. Now if I oxidize it, it will form into carboxylic acid. But if I reduce it, I will get back a primary alcohol. So basically it's the opposite of here. So we're going backwards. So backwards is reduction, forwards is oxidation. So what are the reactants? Now, same case for this one. The stronger oxidizing agent is potassium dichromate, but the weaker one is potassium permanganate, KMnO4. In the reduction part, again, you will see 2. So the first one will be LiAlH4, ethoxyethane, and then you add H3O positive. Now this is one thing, all right? Or the simple one will be NaBH4 and H2O. So either one. Usually we use the stronger one because it ensures there's a reaction going on. So you don't have to memorize which one you have to use strong, which one you have to use weak. Because if you memorize the strong one, it can be applied to any reaction. Whereas if you memorize the weaker one, sometimes it will not work. So aldehyde becomes primary alcohol. So if I have a ketone, so it's just the reverse, I will get a secondary alcohol. Same thing for carboxylic acid. But for carboxylic acid, I'm not going to mention it here because please refer to the carboxylic acid video previously mentioned. Okay? So same thing for this one. For carboxylic acid, all the reactions regarding carboxylic acid, please refer to the carboxylic acid video that I've uploaded on YouTube. So pretty much these are all the reactions you have to memorize no matter what for books 3A and 3B. Because we will be learning organic synthesis and we have done a lot of examples already. For example, if I have given you CCl and I want to have alkene, what are the steps? Okay, so there's no direct way to form haloalkane into alkene. So you have to use other methods, alternative routes. So therefore you have to memorize all of them. So on Monday, basically, I will not be teaching anything. There's no quiz on Monday, so don't worry about it. What I'll be doing is basically giving you all the examples that we'll be doing to refresh your memory first of all, and we will be finishing book 3B on Monday. So throughout that an hour and a half, it will be you doing practice, practice, practice. I will not be talking a lot, okay? So through practice, you will be learning. So if you have not watched this video or you have not, wait, you won't even know if you've watched this video. Anyhow, if you have not revised throughout your summer holidays or you have not done much revision, then on Monday, you will have to do it there. And I'll probably find out which of you have not studied. So again, please do it for your own sake and for my sake, so at least the following 3 days next week, it will be productive because there's a lot I have to tell you. Okay, so looking forward to see you on Monday. Please be on time because our tutorial is at 9. And I will not be waiting for everyone to be seated, and I'll start sharply at around 9:05 because I will give you 5 minutes buffer. Okay, so see you on Monday.